Hi guys, and welcome back to my channel. One of you, Cat Knowledge user of YouTube, asked me, can you make something like magnetic field lines with animation? We love to see. Thank you, Cat Knowledge, for this question. And this is the project for you and for all the people that want to learn something new about geometry nodes and Blender. So let's get started. I'm working with the version 3.6.4. Go to plus button, General, Geometry Nodes, and now we want to create a simple magnetic object. Shift A, Mesh, Cube. We can change the dimension in, for example, 40 millimeter, 140 millimeter. Focus on it, Control A, apply scale, and this is our magnet. Now we want to have curves to create the magnetic field, and to do this we can add a simple curve, Bezier, press New to create a new geometry nodes on this Bezier, because we are going to use a circle line here, translated a little bit, and we're going to create some other curves scaled to show the correct magnetic field around these object. So for this reason I can create here a circle curve. If I press Shift Ctrl and click, you can see it, but the radius is too much. I can set, for example, 100. Now we need some attributes on our group input, like the integer called lines resolution from 3, for example, one other for the lines count. So in this way we can add more curves on our system. We can link the lines resolution in this curve circle, apply 64 for example to have a better curve, but now we need to translate a little bit these, because we want a curve here and next the same curves mirrored to the other side. And to do this we can transform geometry by what? By the radius itself. Now we can press Shift Alt and click on this transform geometry to link directly this output to the group output. Turn on the snap tool, select all these nodes, Ctrl J, F2, single line. Now we need to add some other curves, and to do this we can create points. So we can use these points to instantiate other curves like these, and to do this we can use the instance on point, using these points and the previous object of the curve as instance. Add the group input to link the number of the lines that we need here, and now we need to touch the scale of our curves. So because we want more distance away from the magnetic object, we can't use a linear factor or linear function, but we want to use another method using, for example, the powering of the index of our curves, so our instances. And to do this I need to get the index of our point. In this way I can use the power, link this to a combine XYZ, linking the X because this is the correct road in this direction, and link this to the scale. Now for the Z we can set 1, but it doesn't matter in this case because we want the curves only in the plane where the Y and the X axis stay. And for the Y we can use the index multiply by a value that you need. So we want to increase the scale along the Y and away from the X. So if the index is increased, we want to also increase the Y scale. So to do this we can set 8, for example, link this to the Y, but there is a problem. We have a very high number here for the radius because we are in millimeters, but in this case Blender used the basic unit measure. So in this case we need to scale this vector. It doesn't matter the Z, I remember you, and link these and set the scale to 0.05, for example. You can see nothing because we have no lines count here, but if I set 11 you can see this effect here. Press 7 to see from the top, and we have a problem to the X, so I can increase 1.8 for example, and this is the final result. So we have 11 curves scaled, translated on the X to move the origin point a little bit from the center of the first curve, and this let us to scale the other curves maintaining containing the same origin in the same place, and if you can see, the distance between this point of the curve and the next is not equal to the next, and so on. But it changes because we have a powering here, and if I change this value to 1, we have the same amount of distance between the curves here, okay, 1, 1, 1, 1, etc. But if I set 2.5, for example, now it's exaggerate, but you can see the difference of the distance between the points where the curve is instantiated. And now I set 1.8 to have a balance between the x and the y, and you can see I have the index multiplied by 8 to have a more scaled curve away from the object. Now that we have these curves, we can select all these nodes, Ctrl J F2, scale instances, select all these nodes, Ctrl J F2, lines creation, save the project. Now it's time to create the mirror part to the other side of the x-axis, and to do this we need to realize the instances, because we have instances but we want the original curves from this object. Then we need to transform this geometry to the other part of the x, and to do this we can scale to -1 to the other part and join these together, pressing Shift, Ctrl and right drag, Shift Alt and click to see the result, and this is the mirrored part. Now remember, in this case the indexes of these curves is not the same from this group to this group. So on this side we have the first curves starting from 0 to 10, because we have 11 curves, and the 11th curves index is the first curve on this side, 12, 13, 14, 15, etc. Keep in mind this. Select this node, Ctrl J F2, mirror lines. Now, because this project was born from my previous tutorial about the vector viewer, I'm going to append my previous tutorial to be able to press F3 and add the group of the vector viewer. So if you haven't seen the tutorial about it, you can see it from this link above and in the description of the video. For now, I can remember you that this vector viewer is a node that can create arrows to visualize the pointing from a source position to destination positions with a resolution and some other information to define the single arrow, normalize the scale, etc. We are going to use this as a simple object to create more arrows around these curves, and moving the position, so the source position and destination positions, to have an effect animation of the force of the magnetic field. So before using this vector viewer, I want to use an attractor to change in a dynamic way the shape of these curves that start from here, but I want to manipulate the position of each point of each curve to get a better shape of these curves related to this magnetic field. So to do this, we can't use a simple empty, because an empty hasn't a mesh information, a vector information of points, edges or faces, and we wouldn't be able to use a geometry proximity node to get the correct distance from this object. So I will use the mesh. I can use a plane, deleting the first 3 vertices to get one vertex, or use the single vert to simplify my job. If you don't see this single vert menu, you can enable the free add-on of Blender for extra object, and you can filter with this name in the add-on window of Blender. Next, this is the Attractor. Now we can set on our group input another attribute like the object as the attractor, and you can use a single vertex, or you can use a complex mesh if you want to have a different shape. Now we can set the attractor here, selecting this, add the group input, and now we want to mix the actual position of each point of all these curves and the position of the attractor. So from this attractor I want to have the object information. Make sure to set the relative to be able to manage the origin point of your object in the space, and let Blender follow this information from these outputs. We can get the geometry proximity node. We can link this geometry. I suggest you to use points, but if you have not a single vertex but a complex shape like a cube, cone or whatever, use the faces because these will get a better position and better effort to the mix node that I'm going to use now to get the correct vector to change the position of each point of this curve. So in this case we have the position of the attractor and the original position of our single point. We want to have a factor here, and the factor is the distance. So we want to use the distance as the factor. So more the attractor is near the point, more the point of the curve is affected from this mixing node. We can add a set position here, perfect, and link these to the position. And voila, this is the change of the position. And you can see more beauty on these curves. And if you take the attractor object and press G to move, you can see the correct changing position of your curves. And this is very useful if you are using this effect for two galaxies or two black holes that are touching together. And in this case I will leave the attractor to the center of my magnetic object. Now that we have the correct position of the curves, we can select all these nodes, Ctrl J F2, change lines, position by object. We can create a mesh from these curves and assign a material. So we can add a group input another time, add a new attribute like the float lines radius from 0, and a new object as the material of my curves, lines material. We can use a curve to mesh to transform these curves with a circle curve, link these, fill caps, and use these lines radius here. You can leave 32 for the resolution of your curve, of your profile curve, and we can set the material to this geometry linking the lines material here. From this we can select all these nodes, Ctrl J F2. We can create a new material for the lines material, go here and select lines material. Go in the shading editor, focus on it, increase the resolution to 0.1 for example, and before this we need to use this output in the group output, otherwise we can see the mesh of our curves. Go to the shading, decrease a little bit the radius. We can set a blue color like this and increase the emission to a high value of a bright blue. This emission strength to 75 for example, and this is the result. Turning back to the geometry nodes, we can create the material of our magnetic object. So in the material we can create magnetic material. Go in the shading editor, we can use the coordinate system to get what the generated coordinate system separated in the X, Y, and Z. Shift, Control, and click. You can see the correct gradient from 0 to 1 for all these objects, but we need to have the Y component from 0 to 1. We can delete this principle, link this Y in a color ramp with only two colors from a blue to a red value, and point this to 0.49 for example, and this point to 0.5. Now we can link this color to a normal diffuse BSDF and link this to the surface, and this is the result. We have a north and south magnetic portion of the object. Turning back to the geometry nodes and select the Bezier curve. We can select all these nodes, Ctrl J F2, curve to mesh. Now to use this vector viewer we need to resample these curves using a different resolution, because we don't want an arrow per point, because we have lots of points here, so we want few points. And to do this we can add a new integer in this attribute, setting the vector count from 0. Now we need to resample the original curves here with this new value, so we can use a new group input and link these to a resample curve, linking the vector count inside these, and use these as the base geometry to create the correct number of arrows that we, or vectors that we need to have on our shape. So if I press tab to enter in this group node, you can see we have the base geometry here, the set position, and you can see here in the instance on points we have the points, okay, the resampled curve output that goes here, and we have the arrow, the single arrow instantiated on these points with the rotation and the scale. So for this reason we need to resample the original curves with a few number of points. We can set to, for example, shift control and click, and you can see the result. If I press 10, this is the result. And here we have the point where the vectors will be put. But you can see we have for this curve and the other curves the same amount of resample value. And this is not a very good result, because if we have a bigger curve, we want more arrows than the smaller. So to make the difference, we need to increase the number of the resolution by what? By the index of the curve. So if the index increases, and this is the effect, we want more resolution on our curve. So to do this, we need to get the index, and because we are going to use this index also for the custom scale of each arrow, because if the curve is bigger, we want more arrows, but we want the arrows bigger than the small curves. And if I link the index multiplied by a value blah 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 in this custom scale, I would have an error, because the custom scale is in a point domain here inside this vector viewer. So I want to use the index of this in a curve domain, in a spline domain, to use the same index, so the same scale here, for all the arrows of the same curve. So for this curve I want the same scale for all the arrows on it. For this I want a different common scale for all the arrows on this curve, and so on. So for this reason I use here an evaluate at domain and selecting these as spline. It doesn't matter, use this node here along this path of the setup, this workflow, because here for the resample curve we already are in the spline domain. So here in this context this node doesn't need, but in this direction where I'm going to link the output here in this custom scale, I need to specify the spline domain for use the index for each arrow or vector. I can use the index, I can multiply this value by the vector count here. So keep in mind we need to decrease the vector count, because we already have an increasing of the index as the point, the number of the count for each curve. So if I don't change this value, look what it happens. I link this to the count, and this is the result. It's obvious, I have lots of points, so I need to decrease these. Okay, 1 could be a good value, and you can see this result in this curve. I have, if I count only this simple part, we have 1 2 3 4 1 2 3 4 5 1 2 3 4 5 6, and so on. You can see the increasing of the resolution per curve. But we have a problem. As I mentioned before, you can see the mirrored part in this side gives us a different indexes for the other curves, an increase in this direction, and then from this point in this direction. And you can see the bad result of the resample effect on this part. And to fix this problem, you know that we have the lines count, so this is the number of the line defined by this attribute in the group input, and we can use the output of this index with a module of the lines count and linking these to these multiply. Why this? Because if we have 10 lines here and 10 lines here, we have 0 modulo 10 equals 0, 1 modulo 10 equal 1, and so on. And if I have the 10th line with the index 9, okay, modulo 10 is equal to 9, and this is the result. The first curve from this side would have the index 10, and 10 modulo 10 is equal to 0. And start again. 11 modulo 10 equal 1, 12 modulo 10 equal to 3, 4, 5, 6, etc. And with this simple node, we can mirror the same amount of resolution for these curves. We can use the H, collapse this node, H to collapse this. So Alt S to switch this input, press Ctrl H to this input here, with this a little bit, select all these nodes, Ctrl J, F2, dynamic, resample, curve for vector. We can drop these. Now we need to assign the sources and the destinations positions for our arrows, and to do this we need to capture this information before the resample curve to be able to manage the animation along not this curve, this resample curve, because it sucks the arrows passing from this point to this point along this segment. We want to use the original curve for the animation, okay? And to do this we need to work before the resample curve and after the set position. So here in this point, and to do this we need to move this a little bit, use the capture node here for each point of the original curve. So if I press the Shift, Ctrl and click, these are the original curves, and we want to save the vector for each point of what? Of the position, but keep in mind we want to have an animation, and the animation is equal to move the position of the arrow along the factor of each curve. So to do this we need to sample the position from the factor of each curve, and to do this we need to use the sample curve that let us to have the correct position in the space from a factor of a particular and detailed curve. So we need to save this information, and next we are going to animate what? The factor along this sample curve to have a continuous movement and changing of the position of the arrows along the same curve. So we need to link the same geometry of the curve, otherwise we can't get the correct position, it's obvious. We need to use the spline parameter to get the original factor of each curve and link this factor to the factor initially. In addition to save the position from the factor of each curve, we need to save the tangent information at the same position, because we want to change the rotation of the arrow along the tangent along the curve. And to do this we need another capture attribute here and save the tangent information. So now that we have this information here, we need to use this output to the resample curve. We can drop this viewer for a moment, and we can link the attribute of our position to the sources of the vector viewer and the tangent to the destinations of the viewer, checking the norm and tangent use. I remember you to use this check, otherwise the rotation of the arrow will be wrong. We can add a joined geometry to see the result of our curve mesh and the result of our vectors. We can adjust the initial parameters of our vector viewer, 80 millimeters, 0.13 and 0.3. If I press Shift and Z, I can see the result in the 3D, but you can see this problem. We have a big arrow here, and now we can see some issues. One of these is that you are seeing the result is not, it's not a wrong result, but there is a reason. The reason is that these arrows go up because we are using for all the points of all the curves of our mesh here the curve index 0 in the sample curve. So we are using the same curve for all the curves, for all the points of all the curves. In fact, if I increase these, you can see a different arrows for the second curve, the third, the fourth, and so on. Okay, and you can see the shifting. If I press Shift Z, you can see now the position on another curve, and for this we need to get the correct index of the curve for each point. So because we have here a context of point, and here we need to use a context of spline domain, we need to use the index, but leaving these we are using the index of each point, and this is a wrong result. We want to use the index but evaluated in a spline domain, and because Blender can get the correct index of the spline attached to each point, this information Blender can give you, you can link this value here, and this is the result. We have all the arrows we need. Now we need to fix what? The custom scale. So we can decrease the scale a little bit. This is the result. Shift Z. Okay, now second issue. We have the same scale for each arrow. We don't want this. We want to have a different custom scale for each point based by the vector itself. So if I mute for a moment this link with the Control Alt and right drag, we can see only the curves. You know that each curve has own factor from 0 and 1, a float value from 0 and 1. So we can use the gradient from 0 to 1, remap it to a ping pong effect to have from 0 to 1 and then from 1 to 0 to multiply this scale value and get the correct scale of the arrows. So to do this, we need what? The spline parameter, the factor of each curve. And to do this, we can link this factor to a ping pong value, setting here the 0.5 value. And I remember you, if I have a factor like this from 0 to 1 and I go inside this ping pong, and this is 1, this will give me values from 0 to 0.5 and then to 0. So I need to multiply this result by 2 or divide by the same 0.5 to get the correct values from 0 to 1 and next to 0. Okay, because I want 0 scale for the arrows, maximum scale here at the middle, so here, 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 etc., here, 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 and then 0 to the final part of the curve. So for this reason I need to divide by the same value and next multiply this initial custom scale, so 0.05. We can use a multiply node here, setting 0.08, multiply by this value here and linking this to this custom scale. And if I unmute with Control Alt and right drag this, you can see a little better result. You can see more arrows in the starting point, bigger here, and next the decreasing of the scale. But it's not finished. You can see another issue. Now the arrow near the magnetic object is too big, but away has a correct scaling value. So if we want to have more distribution of the scale, we can use what? We can use the index in the evaluated domain, so the spline, so 0, 1, 2, 3, 4, 5, 6, 7, etc. through this modulo to get 0, 1, 2, 3, 4, 5 also on this side. Okay, remember this, it's very important. Inside what? Inside a map range, and play with these values from 0 to the maximum number of our lines on this side. So I can link the lines count here for the max. In this way I can have the basic starting gradients of the mapping and manipulate these three values here to get the correct result to multiply these ping pong output. So now if I decrease 0.07 or 8 like before, it's not a problem. You can see a different result here. You can see these arrows are smaller than these arrows, and if I increase or decrease this value of from mean, I can manipulate the scale that I want to have here. I can increase the number of the arrows, increasing the vector count here, so the value connected to the resample curve. I can increase a little bit these, not too much, and set 0.06 for example to don't have a touching effect between the arrows of the curve, and this is the result. H to collapse this node. Now we have a static animation, so if I press play we don't have any animation. We want to animate these arrows along the curves, so to do this we need to add an offset to our factor using the modulo with 1, because if I add to a factor that goes from 0 to 1 a value, I can go over 1, 2, 3, 4, and this sample curve node can't work over 1. So if you go over 1 in this attribute, in this node, you always get the position and the tangent of the 1 value, so the last point of the curve. And to avoid this behavior, we need need to control these values by a modulo by 1. So if I go over 1, I repeat the values from 0 to 1 all the time. So I can press Shift, right drag to create a node like this, create a dot here, and now we can add a value, link this here for now, and you can see the effect. So if I add a value to the factor, I move all the arrows in a range, in a smaller range between this number and 1, and all the values that are above 1 get the same position and tangent information, so this point here, and the scale is 0 because we have this mapping range to this resample curve that for the initial index for each group of curves in this side and this side starts from 0 thanks to this module node here, and you don't see the rest of the arrows. So to avoid this, we need to add a value of the offset, okay, that is our animation, and link these to a module setting 1, because 1 is the limit of the original factor, and these can get the correct repeating values for each curve. So if I increase these, you can see I have always the values from 0 to 1. Okay, now we want to animate this value, it's obvious, and for this we can use the scene information, the scene time method. We can add to our group input a float value as the speed we want to use in our setup, add the group input another time, multiply the seconds, so in this way you can change the frame rate of your setup without having problem about the final speed of the arrows. So don't use the frame but use the seconds, multiply the seconds by the speed, and you can use this value as the adding value here in the add H to collapse. We can move these nodes a little bit on the right position. If you have a node inside this section, you can select it and press Alt P to unframe this single node, Ctrl H. Now I can increase a little bit the speed and press play and see what happens. And you can see if I increase the speed, I have more changing of the position and the scale of the arrows along the curves. Now we need to adjust the color of these arrows because we want to go from red to a blue value with a gradient. Not so hard. We need to add some refinement, and we can select all these nodes, Ctrl J F2, get position for each index and animate them. Now to have the correct colors on these arrows, we can use the simple factor attribute of each curve. So we have here the factor, but you need to imagine that going here the position changes for each arrow and the color change, so the value of the factor on the same arrow changes while the animation. So we need to store the information in a variable inside the geometry to pass the correct factor information for each point and to interpolate the values in the shader editor. So to do this, we need to go here, add the store name attribute here in between before the resample curve. I'm using this capture information here because thanks to Blender, the system can interpolate all these values if you resample in a lower number of points the same curve. This is a very huge advantage of Blender and geometry nodes, because if you have some information saved on each point and you have a very big number of points and next you use a resample curve, Blender can interpolate the values of these variables and set the correct linear interpolated value in the new points created here, and is very useful if you need to use this information next. So you can see these values here that are for each point of the curves and not for the resampled curves here is passing through this vector viewer that has a lower number of points, and Blender can use this interpolated information to set the correct source and destination positions of the arrows. At the same time, I'm looking this store name attribute, I'm going to use these in the shading editor for each arrow. So I can save these. The factor is a float number for each point. It's correct. And I need to link what? The output of this module, because this module is always from 0 to 1. Can create a dot here and link this value here. Select this node, Ctrl J F2, factor needed in shader. We can increase the width of this node. Now we don't need to add another vector material because the arrows already has the own material, so we can go in the shading editor here. We can add in the list the vector material to be able to manipulate the shading information. So instead of using this workflow, we can set here the factor, shift Ctrl and click a few times to go to the factor, and you can see we have a value from 0, and this goes from 0 to 1 along this curve here. You can see the gray value here in the middle. We can drop this node here, link the factor in a color ramp, add the two colors from red to the blue color, increase a little bit these two parameters and decrease this value here, link the color here, and link the diffuse BSDF to the surface. And this is the result. We have the factor from 0 to 1 used to have a good gradient from red to blue. Now if I go to the layout, focus on the Bezier curve, set the viewport shading here. I can set here not cycles but EV, for example, checking the ambient occlusion, bloom, it's important, screen space reflection if you want, motion blur if you need. In this case the speed is not very significant. Go down in the color management and set from the filmic to standard to have a more pure color from the RGB color space. Go to the first frame and play the animation, and this is the final result. You can play with these values here. You can increase the lines of the field if you want. You can increase the number of the vectors or decrease. You can increase the speed of the animation. Now I want to show you a little tip. If you want to use a different method to create this curve, it's a final tip that you can use in other projects. So turning back to the lines creation, you can see we have points and we scaled these points using the index. But if I want to use these interpolate curves node, we need to use a new collection. For example, I can rename it in curves guides. I can add a curve inside these like this. I can go inside, press A, scale it a little bit, press G, X, move a little bit. This is the first curve. Inside I can create a duplicate of this curve, and changing this transform pivot point to the 3D cursor, I can scale it down like this, for example, and scale to the X like this. I can exit from this editing by pressing tab, and this is our two curves. You can see these curves. I can go inside this first Bezier curve. If I drag for a moment this Bezier curve here, relative, and get the object information, press Shift, Ctrl and click, you can see this is the result. And if you want to have an interpolation between these curves to create the other curve in between, you can use these fantastic interpolate curves. For no doubt realized instance, link these to the guide curves, because you need these to guide the interpolation. Before the interpolate curve, you need to resample the curve as before, as the initial part of our single line, thanks to this lines resolution. So you need to add the group input and link the lines resolution here in the resample curve. Link this curve to the viewer. This is the result. Now you can use a simple curve line, link this to a curve to point, linking the number of the lines count you need here, and using the points here to instantiate the different curves you are seeing in this moment. So if I press 7, you can see this weird effect. So the reason is because the curve line has the points along the z-axis, but I don't want this transformation. I want to go from a negative value to 0 at the end. So I want to have a line here from this point to this point, for example. And to do this, we need to go to this side to have a good interpolation. You can see we have the interpolated curve not cyclic. So from this output, you need to set the cyclic check, close the curves. You have here an issue because we need to adjust the end, and because you need to translate also the end point in the negative space, because we have the second curve with their own radius. So I need to adjust here by near 50 millimeter, so minus 50 millimeter. You can see this is a better result, and this is a different workflow to create an interpolated curves using a different curves like this. In this way you can change the biggest and the smallest curve to manipulate the shape of your interpolated curves. The distance between these curves follows a linear gradient because we have here a curve line, so all the points created by these curve 2 points use a linear distance from each point. So to have a non-linear distribution of the distance, you need to change the position of these curve 2 points with a set positions node here in between, using a similar approach like this. So the index of each point scaled by a powering effect or other mathematical equation. That's all. Thank you guys for watching this video. I hope you like it. Thank you again, CAD Knowledge, for this question. Don't forget to subscribe to CAD Knowledge channel. You can check the link in the description because it works very well on SolidWorks and has lots of tutorial like my wire netting video. I suggest you to watch it. If you like my work, please subscribe to my channel. Check a like. You can download this project from my Gumroad page if you want, or create it from scratch, and see you to the next tutorial. Bye!